Now, analyzing logic statements can be a little tricky at times because you really have to come up with examples and think of the extremes, whether things work or not. Now, the most basic type of statement is a conditional statement, and this is just an if-then statement. So, in this particular example, I'm going to say, if you are hungry, then you eat. That would be a conditional. Now, if you switch the order around, we call that the converse. So the converse is where you switch the order. So you would say, if you eat, then you are hungry. Now the inverse is like the negative version of the original statement. So you would just say, if you are not hungry, then you do not eat. Pretty much you just add that not word in there. So just the opposite of whatever it said. Now the last thing is the contrapositive. Now the contrapositive is both the converse and the inverse. So you're switching the order and you're saying it's not. So in this case you would say, if you do not eat, then you are not hungry. Now, what's important to realize about these different statements, first of all, just memorize the different words, but they're connected to each other in terms of truth. So like the conditional statement, if that statement is true, the contrapositive also has to be true. And the reason being that they are basically saying the same thing. It's a double negative. It's like when you're younger, if you say, I'm not going to do something, that actually means you are. Now the converse and inverse are also tied together. Their truths match. So if the converse is true, so is the inverse. This is that same double negative idea. Now if all of them are true, then it's called a biconditional statement. And this is an if and only if statement. I'll explain that more later on. Now we're going to look at three examples, and we're going to fill in what's called the truth table. Now a truth table is a tool that you can use to help determine the connections between the different statements. Basically, you start off with a statement. So if a person is tired, then you go to sleep. Okay, so you ask yourself if that's true or false. I can come up with a counterexample which proves it's false. Like right now, I am kind of tired, but I am definitely not asleep. So that would be false. Okay, sorry, I'm having a little trouble clicking here. So I'm going to move on to the next thing. Now the converse, again, is where you switch the order. So we're going to switch the order of it. So we'll say if you're asleep, then you're tired. Again, I don't think that one is particularly true because sometimes you'll go to sleep and you're not tired. You just happen to fall asleep. Or you have to go to sleep because you know you need some rest. Now, if you do the negative, the inverse of it, you would say, if I am not tired, then I did not sleep. And again, they're tied together. So if the inverse is false, so is the converse. All right. Now, the contrapositive would be the double negative of the original statement. So if I am not asleep, then I'm not tired, and you automatically know that the truth is going to match whatever the statement is. So if the statement was false, therefore our contrapositive will also be false. Again, it's because it's a double negative of itself. All right, so in this case, all four of these are all false because we proved examples to the contrary, which are called non-examples or counterexamples. I'm sorry. All right, the next statement we have: if a figure is a square, then it is a regular quadrilateral. Obviously, you need to know what the word regular and quadrilateral means. Regular just means all equal sides and angles. Quadrilateral is a four-sided figure. Basically, that's a definition, so it is most definitely true because a square, by definition, is a regular quadrilateral. All right. Now, also, the contrapositive has to be true because, again, they always match. So the contrapositive would be if you're not a regular quadrilateral, then you are not a square. So, again, I normally, if the statement's easy to figure out, you know the truth of the contrapositive pretty easily. So now the converse is where you switch the order of the original statement. So you'd say if it is a regular quadrilateral, then it is a square. This is, again, by definition, that's what a square is, so that's definitely true. And the inverse would also be true because they're related. So the inverse would be if it's not a square, then it's not a regular quadrilateral. Always be careful when you're doing the inverse and contrapositive. Don't mix them up. Remember, the inverse is the not of the original statement, so you just say not of whatever it is. All right. Now, in this case, notice how they're all true. Because since they're all true, this is called a biconditional statement. This is one of those cases where you could use an if and only if phrase. For example, you'd say, a figure is a square if and only if it is a regular quadrilateral. And the reason you can say that, because it's by definition, a figure is a square only if it is a regular quadrilateral. All right. So go ahead. We're going to look at the third example. The third one is talking about if you go into a pool, then you will get wet. So again, our P is the pool part. So if we're going to the pool, and our Q is the get wet part. So if you go into pool, then you get wet. That is false because, oh no, I'm sorry, that's true. If you go into a pool, you would get wet. But a pool is full of water, so obviously you have to get wet. All right, the converse would be if you are wet, then you're in a pool. Well, that's not necessarily true because you can go in a shower and get wet, so that you don't necessarily need to be in a pool to get wet. And again, they're related. The converse is related to the inverse, and the statement is related to the contrapositive because that double negative type concept. All right, and that's how you analyze the truth of logic statements.